Hello everyone, this is Vishwas and welcome back to our YouTube channel Front End Devs. I'm working in software industry from past 11 years and with my experience I'm creating the high quality content on YouTube for front end developers. Whether you are starting your web development journey or want to level up your skill, then you have got covered in this channel. I'm starting brand new playlist on React 19 features, and as a part of this playlist, we will explore all the important features one by one, which includes amazing performance optimization with React compiler. We will understand the actions for streamlining the form handling in React 19, then optimistic updates, server-side rendering, and all the improvements around the existing React features. We know that React 19 is stable now, and we can start using all those features in your application. As a part of this playlist, we will understand all those important features with the help of practical implementation. At the end of the video, I will add all the code of that video to the GitHub and add the link in the video description so that you can clone that repository and try to implement things by your own. So without any delay, let's start for the today's video. And in today's video, we will understand first important feature of React 19, and that is React compiler for amazing performance optimization for your React application. When we talk about the React compiler, we previously known it as React Forgot, and it is an experimental build tool designed to automatically optimize your React application by memoizing the values and hooks within your React components. That means it is the static compiler which will analyze your components and automatically insert the memoization when needed. You can think it as a React with built-in intelligence. Internally, this compiler will do the required optimization. That means adding the necessary React.memo, useCallback, or useMemo hook to avoid the re-render of component if that is not needed. We don't need to do that manually. One important thing, React compiler is not part of the React. It is a separate package and that is still under the RC phase. That means release candidate. When we working on React 19 project, by default React compiler is not enabled, and explicitly we need to install the React compiler package to enable this optimization for us. If you go to the official website and see about the React compiler, you will see the React compiler is new compiler currently in RC, and that will be open source to get the feedback from the community. Also, if you go to the down, it is the separate package, and if you want to support or enable those optimization in our React project, we need to install those packages separately. We have the package called Babel plugin React compiler, and we can also install the ESLint plugin to get some recommendation around the usage. Here we have more details about the React compiler, and in order to optimize the application, basically React uses the React compiler and it automatically memoizes our code. All through it will do the optimization for useMemo, useCallback, and React.memo, and we don't need to add them manually in our project. The compiler internally doing that for us. And as I mentioned, this still in the RC phase, so you might face some challenges, or some of the functionality may not work as expected when we are using this React compiler. To understand the React compiler, I have created a couple of demo projects. This is very simple project around the counter, and we will understand how exactly we can use the React.memo, use callback, and use memo manually in React 18 project. And then we will see how exactly React 19 compiler handle those automatically. So first, let me go to the VS Code and understand React 18 project in short. In VS Code, this is my React 18 project. If I go to the package.json, you will see we are using React 18. And then if I go to the app component, here we are managing two counter. So I have separate state for them. Then I'm just logging the render message of app component. I have a couple of handler to increment my counter. The first one is for counter 1. This is for counter 2, and below I have a couple of buttons. When I click on respective button, I will increment the respective counter here. Then I'm calling the parent component here. This app.js is my topmost component. Inside that I have a parent component which is present here. Here I'm just logging some message, and again I'm calling one more component here, that is child component. Child component is also very simple. I'm just logging some message and I have heading here. And if I go to the app component, I'm adding one more function here. The function name is expensive calculation. For that, it is doing very simple calculation, but you can assume this function is doing the expensive calculation, and we will understand how exactly we can memoize it with the help of useMemo. Now I have run this application, and if you go to the Chrome, you will see our application is rendered and it prints all the required log here. First, it comes to the app component, then it prints the expensive calculation log, then it comes to the parent component, and then it comes to the child component. You are seeing log twice here, but that is due to the strict mode. And in strict mode, React makes sure that the component rendered twice in the development mode to catch error as early as possible, or to avoid any unexpected behavior. Now, if you go to the app component, you will see we are calling the parent component from here, and then we have child component that is rendered inside your parent component. When we do the initial render, printing this kind of log is absolutely fine. But now let me clear this, and when I click on counter 1, you will see we are managing the state in your app component. But still your app component as well as your parent and child components are re-rendered. Same thing will happen when I click on counter 2, and if you look at here, we are only managing the counter 1 and counter 2 state in our app component, but still our parent and child components are re-rendered unnecessarily. And we can avoid this re-rendered by using React.memo. Let me go to my parent component. Then we can import the React memo. Just let me do the import memo from React, and we can wrap memo around our parent component. Let's save the changes. We know that what memo is doing, right? Memo is basically memoizing the props that we are passing to the component, and if that props are not changed, then this memo will avoid the re-rendering of your child and any component that is used in the hierarchy down. But we should use memo with caution, because it also adds the performance overhead. Because each time when the components re-rendered, it needs to do the comparison of the props that is used previously and the new props here. Now let me save the changes, and you will see the difference. Let's clear it. Initially, our components rendered as it is. That means all our components are rendered in the component hierarchy. But now you will see the difference. When I click on the counter, you will see only app component is rendered here, and it rendered the expensive calculation logic. As we are not passing any props to our parent and the child component, React memo avoid re-rendering of them. Same will happen when you click on counter 2. And this is how we can use the manual React.memo. Hope you are clear with memo. we are just understanding the use of a memo, use callback, and use memo in React 18, how exactly we need to use it manually to avoid the re-render, and then we will understand how exactly React 19 compiler handle those automatically. Now let me tweak this code a little bit. What I will do, I will go to my app component and now I will pass some state from here. Let me pass the count one as a props from here. And then I will use count one here. Let's save the changes. I'm just passing the props from here, but I'm not using that in parent component yet. That is fine, but still we will see the difference. Let me click on counter one, and now you will see along with app component, my parent as well as child component is rendered because I'm passing the counter one to it. And every time my counter one is updating, and which will cause the re-render of our app component as well as your child components. But same thing, if I do with the counter 2, we will see only app component is rendered because counter 2 we are not passing to the parent component, and here React.memo avoiding re-rendering of it. Let's do one more thing. Instead of using this button here, I will use counter 1 button in my parent component. Let me use it before child, and then you will see the difference. Let me also pass this counter 1 as a props to parent component. We will use the counter 1 handler, increment counter 1, and it should be a increment counter 1. In parent component, use both the props. The first one is counter 1 here, or this is count 1, and the second one is this increment counter 1. Let's save the changes, and now if I go to the application, you will see when I click on counter 1, your app component as well as your parent and child components are re-rendered because we are passing counter 1 as a props to it, and that is expected. But now when I click on counter 2, you will see the difference. Instead of just rendering the app component, we will see parent as well as child components are rendered. And that is because we are passing increment function as a props to our parent component. Whenever our components re-rendered and this increment counter function is passed, each time new copy of this counter function gets created. And when we go to the parent component, and here memo is considering the previous counter 1 and new counter 1 as a separate function. This is simple, right? Both the functions are exactly same, but the function are basically the object in JavaScript, and both the objects are pointing to different memory location, and if we compare two objects, that basically give the false result. And to avoid that, we need to use callback hook now. When we want to memoize the function, we need to use the use callback hook. Just as a use state, let me add use callback here, and we need to use this callback around your counter 1 function. Just let me convert it into the function first. This is my counter function 1, and then whatever this counter function 1, I need to wrap it around the callback, and this callback will expect dependency. This dependency same as the use effect, and we need to use count 1 as a dependency here because we are updating the count 1 logic, and then we just need to return this use callback result here. Let me remove the typo, and now let's save the changes. Things are very simple. We need to use the use callback function. We need to wrap it around your increment counter function, and it will expect some dependencies. In our case, count 1 is used inside this function, so we need to use the dependency as a count 1. And this use callback will return the memoize function, and we are storing it in the same variable. Now we are passing that same variable down here, and now our function gets memoized. If this function is not changing, then our component will not re-render. Let me go to the application again, and if I click on counter 1 now, that is working as expected, because whenever counter 1 update, we are passing that data to the parent component. But now when I click on the counter 2, it is only rendering the app component, because here we don't have the dependency of counter 2, as well as we have memoized the increment counter 1 by using useCallback. Now let's understand the manual use of useMemo, how exactly we are using it. If you look at here, we are doing some expensive calculation, and that calculation is only depend on count 1 here. But if I go to the application and try to increment the counter, we will see the expensive calculation is calculated here. But if I increment the counter 2, right, still my expensive calculation is calculated. And we can avoid this by using the useMemo. This hook is same as useCallback, but useCallback is used to memoize the function, and useMemo is used to memoize the value. Let me copy this and add it around this expense function. We can do something like this, and here we need to use the dependency. Dependency is count1. Yes, till now this is function, but now it is storing the value, and instead of calling this function, now we just need to use the expensive computation. Let's save the changes, and now if you go to the browser, you will see the difference. When I click on counter 1, you will see the component is rendered, that is app, parent and child component, because we are passing the required state, and we are doing the expensive calculation on your counter 1. But when I click on counter 2 now, you will see only app component is rendered. This way we can avoid the re-rendering of child component. We can memoize the function by using useCallback, and we can memoize the result by using useMemo hook. And if you want to do this optimization with React 18, all we need to do it manually. We need to add the respective useMemo, useCallback, and React.memo to avoid the unnecessary rendering of your child components. Now I will go to the second application that is created with React 19 with same code base, and then we will understand how React 19 handle those optimization inbuilt for us with React compiler. Now in VS Code, you will see the React 19 project. Here I'm using React 19 version, and the rest of the things are same for this project. Here I'm using the app component. We are managing the to state, and I'm not using any kind of optimization here. Same way, if I go to the child component, and if I go to the parent component, you will see currently we don't have any optimization. And to enable the React compiler with React 19, as I mentioned, the React compiler is not part of the React, and still it is in RC phase. But if you want to enable it, we need to install the required packages here. The first package is the Babel plugin React compiler, and then we can go with the ESLint plugin. And we need to add that compiler in our Vite config. Here I have added the Babel compiler with target React 19, and now it should handle optimization for us. Now let's see what all optimization it can handle. And for that, let me refresh the page. When I refresh the page first time, you will see all the components are rendered, and that is fine. But now when I click on counter 1, you will see only app component is rendered. When I click on counter 2, again you will see only app component is rendered here. You will see the expensive computation is not handled automatically by React compiler, and for that we have used the useMemo. It could be the issue with React compiler still, and it might not able to handle those use memo things, but it will be a fix when there is improvement in React compiler. But you definitely see like it handle the use case for React.memo. In our case, what we did, like we wrap the your parent component, right? Parent component is wrapped with React.memo to avoid the unnecessary rendering manually in React 18. But React 19 handles it automatically. Let me tweak code a little bit now so that we will understand it in more detail. We will do the similar thing that we did in React 18 app. Let me pass couple of props here. The first one is count 1, and we will also pass the increment counter 1 function here. We will pass it as a props. Let's save these changes. Let me also cut this button from here, and we will call this button in our end component. Let me add this here, and now we will use those two props. The first one is counter 1, and then we will use the increment counter. Let's save the changes, and now we are understanding how exactly React 19 handles the use callback automatically. It should memoize this increment counter function when we click on counter 2. First, let's click on counter 1. This is working as expected, but now you notice one more thing. It is just rendering the parent component. It still added the memoization on our child component, and that is great thing, right? And now when I click on counter 2, you will see only app component is rendered, and it's automatically handle the use callback optimization for us. This is great. Still, React compiler is in RC phase, and we might facing some strange cases like handling the expensive operation like use memo, but it will be covered soon. Here it is not handling the use memo operation, and in this case we can go with manual implementation, same as we did for React 18. Hope you are clear with what is React compiler and how it will help us for the optimization in future or when this React compiler is stable. I think that's all for today's video. In next video, we will understand few more interesting concept around React 19. Thank you for watching, and see you in next one. Till now, thank you. Bye.